Now that we know that roots and zeros and x-intercepts are all the same thing, let's talk about what actually happens at those roots. So that's what we call the behavior at the roots. So let's take a look at an example here. The behavior is determined by the exponent on each individual factor. So this first one here, since it has an exponent of 1, we call that a single root. So what that means is, on the graph, and this would be crossing my x-intercept at -1, so that means at -1, no matter what the rest of the graph looks like, at -1, a single root will simply cross directly through that point. So a single root is what we call a cross behavior. Now, if something has a square in the exponent, so an exponent of 2, we call that a double root. And what that means for the graph is at that x-intercept, which in this case would be a +2, a double root is going to bounce. So again, no matter what the rest of the graph looks like, let's say it's coming from here, a bounce means it's going to hit that spot and it's going to turn right back around. The same thing would be true if it was coming from the bottom. It would hit it and it would turn right back around. So that behavior is what we call a bounce. And now the last one that you guys will see is when a factor has an exponent of 3, which is obviously going to be called a triple root. So what that means for your behavior on the graph, since this is a x plus 3, your intercept would be at -3. So over here, a triple root is, and again, no matter what the rest of the graph looks like, let's say it comes from down here, is it's going to approach it as if it were going to bounce, but it's going to flatten out and then it's going to go back up. If it were coming from up here, it would look like a parabola, but then it's going to flatten out and then it's going to flip and go down here. So this is what we call a bend, or some people like to call it a curve.